So today we're doing what's called foldable notes, and we're doing kind of an overview of the entire chapter 9. So this would take pretty much the whole class as we walk through. So as you're taking a look at this, translation is in the upper left, a figure that is slid in any direction. So we go from pre-image to image. So in this one would be slid to the right and down. It keeps the same shape and size. To the upper right is a reflection. A figure is flipped over line. In this case, going from the pre-image to the image that would be reflected over that line, which is the y-axis. And we're going to go through this in detail. I'm just kind of give you an overview. Bottom left is a dilation. The figure is enlarged or reduced. In the example that you see, you have a pre-image, which is small. The image is big, so that's going to be an enlargement. The bottom right is a rotation. Figure is turned about a point. Pre-image about a point. So again, now let's go into, this would be the very back of our notes. Again, you can read through these. Transformation, definition, a movement of geometric figures. Pre-image, the position of the figure before the transformation. Image is the position of the figure after the transformation. An isometry definition is when a transformation preserves the size of the transformation. Continuing here on the back of notes, line of symmetry, figures can be folded, so two halves match exactly. Point symmetry of a common point of reflection for all points. And then these are some very good notes to see where we're at. So when you reflect over the y equals x line, you're going to take your original ordered pair xy, and you're going to flip those two around to make it yx. If you're going to reflect over the y equals negative x line, which we don't do that one, but that's what that would look like. Reflect over the x-axis, you take your original ordered pair, xy, and it becomes x negative y. You reflect over the y-axis, xy becomes negative x and y. Down here with the rotation, and if we go CW means clockwise, CCW means counterclockwise. So if we're going to go clockwise, 270 is the same as 90 clockwise is the same as 270 counterclockwise. And in that case, you take your original xy, and it becomes y negative x. If you go 90 degrees counterclockwise, you take your original ordered pair to negative yx. And if you go 180, which is either clockwise or counterclockwise, it's going to be in the same spot. You get negative x, negative y. So now we break it down. If we were doing our foldable notes, this would be underneath the flap of the upper left. Translation is to when you move the object and it keeps the same shape and size. To translate horizontally, you add or subtract from the x coordinate. Translate vertically, you add or subtract from the y. So in this example right here, we are going to take our original ordered pair, which you can see is in green, and we're going to translate it, and we're going to call these here, we're going to call this new one is A prime. So after we move it with the vector, that's why we just studied vectors of negative 2, 1. So we're going to take our ordered pair. I start with A. If I go negative 2, 1, so I'm going to go 2 to the left, and I'm going to go up 1. This is my new A prime. So that's what that would look like. And so then I can write down that new ordered pair just so we get an idea of where we're at. So you can fully understand, you know, what we're trying to do and the location of where we're at. Our new location is going to be negative 1, 3, negative 1, 3. So a couple different ways that you can do that. You can just do the math like we did with vectors. Negative 2 plus 1 is negative 1, and then 1 right here plus 2 is 3. You can see when we moved it on the coordinate plane from the origin, we are now located 1 to the left and 3 up, so that's our A prime. Next is our B is at 3, 4. So again, if we go negative 2 and up 1, this is our new B prime. And so you can either just do the math. So negative 2 plus 3, so B prime is 1. And add 1 to 4, and you get 5. And again, that should match the location of where we are at with our B prime on the board. And C prime is going to be, so we have negative 2 minus 1, so negative 3. And 5 plus 1 there is going to be 6. Or you can go right from the ordered pair. If I go 2 to the left and up 1, this is my new C prime, and it should be at the same location, negative 3, 6. I know this board isn't always going to work, but that would be our new triangle. That's a translation. It keeps the same shape and size. It just slides or moves it along the way. That's called a translation. Next here we have a reflection. To reflect over the x-axis, multiply the y-coordinate by -1. Reflect over the y-axis, multiply the x-coordinate by -1. To reflect y equals x, we have our original ordered pair xy becomes yx. This example, they want us to reflect over the x-axis. So we are going to reflect over the x-axis. So that means that we're going to go with, we're up here, so we're going to reflect over the x-axis, multiply the y-coordinate by -1. So the x stays the same. We now have an a prime. X stays the same. This becomes 1, -2. So this is our a prime. You reflected this as the x-axis right here. So you're just flipping it over basically. For b prime, the x stays the same and your y becomes -4. So we have 3, -4. That is our b prime. And then our c prime here is -1, -5. And yes, if you did have a negative, it would become positive. So this is a -1. And this is our c prime. So this right here represents our new triangle, basically flipped over. Now again, if you did the reflection over, let's say we reflected over the y-axis, and I'm going to show that just because it intertwines. I'm going to start with the original here. Okay, start with the original. If I reflect over the y-axis, you multiply the x by -1. So my a would be -1, 2. So -1, 2, this would be my a. I'm just going to call this a double prime just to kind of show you where that's at. So this would be, let me go down here. A double prime would be -1, 2. B double prime, if we went from there, if we reflected over there, we multiply the x by -1, so it'd be -3, 4. So -3, 4. This is our B double prime. And then C double prime actually goes and flip-flops across. That becomes a +1 and 5. That's why I wanted to show you this one. 1, 2, 3, 4. And then what happens is you can see they kind of overlap. And that's how it should go. That's how it goes sometimes. Next one is called dilation. To dilate a figure by a scale factor of k, you multiply both coordinates by it. If k is greater than 1, the figure is going to get larger. If k is less than 1 but greater than 0, the figure is reduced. So that would be a decimal. That would be like multiplying by 0.5. That would make it smaller. So in this case, we have a number that's going to be 2. So we're going to take all of these numbers and multiply them by 2. So a prime is going to be 2, 4. Whoops, what happened here? I wouldn't have that there. So a prime is 2, 4. And now this figure gets bigger, so it kind of overlaps and intertwines with the other figure. But that's just how it goes. B prime is going to be 6, 8. B prime, and then C prime is going to be -2 and 10. -2, 10. So that's going to be our new triangle there. So that's a dilation. Last one here is a rotation. Most times we rotate about the origin. You can rotate against other points. And then take a look and see what we do from here. So first one says that this kind of gives you an idea of what you do. And then this example says right here we want to rotate 90 degrees counterclockwise. So this says 90 degrees counterclockwise. So we're going to flow with that. We're going to get a prime. So we go from xy to -yx. So y, this is -2, and this is 1. So -2, 1 puts a prime there. B prime is, so we take the -4, 3. And C prime is we take the reverse here, so -5, -1. So this is what C prime will look like. And then let's connect those, folks. And then what I want you to look at here is when we say 90 degrees counterclockwise across the origin. So if you draw a line from here through the origin to point A, this right here is 90-degree angle. If you do the same thing with B and C, that would show you a 90-degree angle. So that's kind of how that works. Great job, folks.